Welcome back, guys. Today we are going to see what is implicit wait in Protractor and how it affects element and element.all methods in Protractor. Okay, without any delay, let's start this tutorial. So what is this implicit wait? Basically, what is the wait? Okay, so before discussing that one, let's see an example and understand like why we need wait and what is wait. Okay, so for this purpose I'm going to use this web page which is like CherCherTech/practice/implicit-wait. Okay, so you can get this particular URL from the description. Okay, if you refresh or if you open this page, you might not see any checkboxes in this page. Okay, so if you read it here, every checkbox takes 10 seconds of time to present. Okay, now see, we got one checkbox here. Okay, previously there was no checkbox, and after 10 seconds we will receive one more checkbox. Okay, so similar way we will receive continuous checkboxes with the interval of 10 seconds. So what is wait? Okay, so here it takes 10 seconds to get this checkbox into the web page. Okay, so what happens is like whenever we use automation tools, they will load the web page, and the moment the web page is loaded, it will try to find that particular element and then try to perform the operation on those elements. But here it takes 10 seconds to appear, but the automation tools like Selenium or Qtp or any tool for that matter will not know that how much time it's going to take. So we have to sync the application speed with our automation tool. Here in terms we are using a protractor, so we have to sync the protractor speed with application speed, or we have to wait for something till the thing is present. Okay, so this is the thing we have to do, but if you go on like that, then it will be difficult. So sometimes like we can use a browser.sleep, which is a dead wait. Like whenever you use a browser.wait, it will wait for that particular amount of time, and it will not perform any other operation during the sleep time. Okay, it will perform after sleep only. So let's try with the browser.sleep, try to find it. But before that one, let's try to find the element after opening that particular web page. So by dot element command is used to find an element. Okay, something like I'm good at XPath, so I will be using XPath dot click. For moment's sake, I'm creating the dummy code. Okay, so this is the normal syntax for clicking any element, but now we have to find the XPath for this particular checkbox. Okay, it's all the checkboxes has same kind of properties. Now let's inspect one checkbox. It has tag name as input and type as checkbox. These are present under the division called division which has id as q. Okay, so we can write /div at id equal to q. Okay, /input. So this is going to be the XPath for the checkboxes. Okay, it will match all the checkboxes. See, we can match all the checkboxes, which are 8 so far present, and it will the application will continue to populate the checkboxes. Now let's copy it and try to click that particular checkbox, the first checkbox. Okay, now shall we run it? Let's run. So it's about to start. Should open the browser now. Yep, and navigate to that URL. Let's see. Yeah, it's opening the URL, and yes, it's loading. The page is still loading. So basically Protractor will wait till the page gets loaded. So we got our checkbox. See, we have 0 failures and 1 spec is passed. But if you see, Protractor waited till the page got loaded. But what if the page loaded earlier? before 10 seconds. Will that checkbox be present there? Okay. Oh no, it will not be present. Okay, so let's run it again and see how stable this particular test case is, because we are not having anything, is any sleep or wait. If the particular application takes 10 seconds, then the particular checkbox appears, so the protractor performs the operation. But if the application is loaded in 4 or 5 seconds, then protractor tries to find the element in a moment. But the moment it tries to find the if the checkbox is there, then it's okay, otherwise protractor throws an exception. Now we received an error saying that there is no element found using a locator called xpath with this particular input. Basically that particular checkbox is not present. Okay, it waited for 10.61 seconds. Okay, there could be a difference after loading. Okay, now it's over, but last time it got passed and this time this one got failed. It is because of the loading time. Sometimes the application takes more time to load and sometimes it takes very less time to load. So our test case shouldn't be depending on the time of loading. Okay, it's always should be stable. So for that we can use browser.sleep. Okay, before finding the element, browser.sleep, like I can give 11 seconds. Okay, so this command will wait till the page gets loaded, and after that it waits for 11 seconds. Okay, so then only it tries to click the particular element. Now obviously the element is going to be present. Okay, let's run it. Okay, this time it shouldn't fail. It's running. It's opening the web page. Let's see whether it gets loaded before 10 seconds or it takes more time. Page got loaded and now it is sleeping for 10 seconds. Okay, the checkbox appeared. Now let's see the result. The test case is passed because we have added 10 seconds of sleep. So what this sleep does is, like, it will halt the total protractor for 10 seconds. Okay, it will not allow the protractor to perform any other operations. It will hold all the operations. So which means, like, if the checkboxes appeared on the very first second, then this browser.sleep still will be sleeping or making that particular protractor to sleep for 11 seconds. Okay, so it will not allow any other operations. So even though our element got present at the first second, why would we like to have 11 more seconds to waste, right? So this is the issue with browser.sleep. It is a very static wait. Okay, even element is present, it will not try to perform any operations, and also it will hold a total protractor for 11 seconds. So this has this disadvantage. Even when it's the element is present in the first second, we are waiting for 11 seconds. Okay, no one wants that, because in one test case, if you are for one element you are writing for 10 seconds, means if you have like 1000 test cases, then you might be writing so many waits or so much of time of sleep. So to avoid this one, Protractor introduced implicit wait and explicit wait. So we are more going to focus on implicit wait in this video. So implicit wait is nothing but you wait for the element, but the moment the element is present, then no matter what, you don't wait for the element anymore. Okay, or you don't hold any process from the protractor. Okay, this is what the principle behind implicit wait. I hope I made a little sense. Let me explain it again. Okay, consider like you are waiting for your friend. Okay, and you are planning to go for some movie or some place, and the moment your friend comes, will you still wait or will you go along with your friend the moment he comes? So the implicit wait works in this strategy only. The moment it finds the element, it proceeds with the next operation. It will not stay there for the given time. Something like if I am giving an implicit wait of 30 seconds, and if the element is present in the first second, then what happens is like the implicit wait will try to find that particular element, okay, within 30 seconds. If it finds in the first second, then it will not wait for another 29 seconds, or it will not waste another 29 seconds. So without wasting, it will go for the next step in your code. Okay, so we have seen like what's the disadvantage with sleep and what is implicit wait. So let's implement. So implicit wait is present under the timeouts class. Okay, timeouts interface or class. So we can access it using browser.manage. okay, manage is a method dot timeouts dot implicit wait. So this implicit wait accepts the parameter in milliseconds. Basically this is nothing but how much time we have to wait for a particular element to appear, the max time. So as industry standards it gives like 30 seconds, so I am also giving 30 seconds. It accepts in milliseconds, so the 30,000 becomes 30 seconds. So we have given the implicit wait and we are trying to find this particular element, okay, using this particular XPath, and then we are trying to click. Okay, so previously what we have seen is it waited for 11 seconds, okay, with the sleep, but here it shouldn't wait for 30 seconds. Okay, now let's run it and try it, and let's see whether it works or not. Now browser started. Okay, now browser opened. We should open the URL. It's opening and it's loading the page. Now load is over, but checkbox is not present. Checkbox is present and it was able to click it. We did not get any error. The total execution was over in 12 seconds. Okay, so if you want to see more clearly, let me add browser.sleep of 5 seconds. Okay, so that you can see like whether it clicked or not. So this time the total execution will consider this 5 seconds as well. Approximately it comes like last time it got 12 seconds. It should now 12 plus 5, about 17 to 18 seconds the total test case will take, based on the loading of the web page only. Web page loaded. It's still waiting for the checkbox. Now it clicked. See, now it's sleeping for some time. Yep. So it took total of 17.136 seconds. So this is the beauty of implicit wait. So even you give 300 days or 300 years, it will wait till the element is present. And second important thing about implicit wait is like it is applicable for element, okay, element method, and one more method called element.all. okay, you just got to remember it. What all? Only these two methods will be using implicit wait. Okay, so this element.all uses in one condition, in only one condition, or you can say it only one situation. In remaining situations, element.all will not try to wait for that particular implicit wait time. Okay, so implicit wait means it directly applicable for element, but for element.all it's applicable on only one condition. Okay, so what is that element.all condition? So whenever you use implicit wait along with element.all, what happens is like whenever there is an element, consider like if you go to this same web page and let's refresh it. So now we are trying to find the element all. So what happens is like it will try to find at least one single checkbox here in this page. Okay, that element.all. The moment it finds the first single checkbox, it will not wait any further. Okay, consider like this total web page has 1000 test cases, but only loaded 59 checkboxes. So what happens with the element.all is it will not wait for all the 1000 to load. It will, the moment it finds at least one single checkbox at a time, at the moment when it queries, then the moment it moves on to the next statement. So let's try this one in now. Okay, so I'm going to try dot all. Okay, now let's get the count of it. Count dot, it returns a promise, so we have to resolve it using a then block. Total is a parameter here. I'm giving it as a variable so that this total count will be stored in this here in this variable. Okay, let's print the total number of checkboxes. Okay, what should happen is it will open the web page and it will try to find number of checkboxes there. Okay, with max of 30 seconds of implicit wait. Not this one. Wait for this Protractor to open the web page. Yes, we got the web page and still the web page is loading. Now let's see how many checkboxes it's going to print. It says total number of checkboxes is 1, but this is the same page. Let's refresh it. Let's see how many checkboxes are going to present. Okay, it will generate infinite number of checkboxes for each and every 10 seconds, once in every 10 seconds. Okay, now one we got. In another 5 seconds we will receive one more checkbox here. See, but what we got here is like only one. So whenever we use implicit wait, the element.all will wait for at least one particular checkbox to present, at least one match, not a checkbox but at least one match. If one match is present, then it will move on, but if there is no match, then it will wait for the total given time. Okay, but this element dot will not try to find all the elements. Okay, so it will always try to find the number of elements present at the time of query. Okay, this will query the DOM of the web page. Okay, so based on that one it will give the values. So I hope you guys understood what is implicit wait and how it is applicable to element and element.all. Okay, so let me give a recap of it. So implicit wait is a dynamic wait. Okay, so it will wait for a particular element to be present, or basically it should be present in the web page, okay, with the given time. Okay, here we are giving implicit wait accepts in milliseconds. Okay, so here we are giving 30 seconds. Okay, 3000 milliseconds. The moment the implicit wait finds the element, then it moves on to the next step. It will not hold for the remaining time. Something like if you have given maximum time of 30 seconds, but if the element is found on the 4th second, then after the 4th second itself it will move on to the next step. It will not wait for another 25 seconds, whatever is left. Okay, so this is the one of the biggest advantage of implicit wait. Okay, so in element.all will wait for at least one particular match to present. If no match is present, then only it will wait for max this time. But if it finds at least one match, then it moves on. It will not wait for all the elements to be present. Okay, so with all this thing we can end the video, but just before ending it, know that implicit wait is not a good dynamic wait, and we shouldn't be using implicit wait, even though it has so many advantages, but we shouldn't be. So please do watch my explicit video thing why we shouldn't be using implicit wait. Okay, but most of the time implicit wait is far better than browser.sleep. So if you have any query, please do comment, and if you like our video, please do watch some other video and increase your knowledge on the protractor or on the waits. Okay, with all that, bye.